So in this video I'm going to explain how this Bistable 555 timer circuit that I'm using for my 16-bit computer works. Okay, so at the moment for our clock for our 16-bit computer we have two outputs. We have a astable automatic output and we have a monostable manual output. So when we push a button the output goes high, otherwise it's low. And so we need a way to switch between these two modes, and your first thought for that might be just use a switch, but with the switch we have the same problem of bouncing, so now we need to debounce this switch. Well, rather than use a switch and debounce that, I've got two buttons and I'm just going to debounce them, but still with the 555 timer by using the bistable mode for the 555 timer. And so like always, before I start explaining how it works, I'm just going to run through what's hooked up to the 555 timer. So on pin 2 I have a 1 kilo ohm resistor connected to 5 volts, so it's being pulled up normally, and then I have a button connected to ground at the input and the output's connected to pin 2, and at pin 4 I have the exact same setup. At pin 3 I have the LED with the 220 ohm current limiting resistor, which is then connected to ground, so this is the exact same as the astable and monostable circuit, just so we can look at the output. Pin 6 is directly connected to ground, and then pin 5 is the same as the astable and monostable. It has a 0.01 microfarad capacitor connecting pin 5 to ground. And then pin 7 isn't connected to anything, and pin 8 is connected to 5 volts and pin 1 is connected to ground. So now I'm going to run through how this will work. Okay, so you just powered this on, and let's look at the reset pin, which is pin 4. So that's directly connected to 5 volts through this 1k resistor, and because reset is active low, you can see that there's an inverter here, this isn't going to be resetting. And now we can look at pin 2 is also directly connected to 5 volts through this 1k resistor, and 5 volts is larger than 1.67 volts, and since the 5 volts is connected to the negative input for the comparator, you're not going to have the output for this comparator going high. So neither of these inputs of the SR latch are high, but one of the outputs has to be high because this is Q and then this is whatever Q isn't. So if Q is low, then this has to be high, but if this is high, this has to be low. So one of them has to be low or high. So let's just say Q is high and not Q is low. So if Q is high, the output's going to be high and this LED is on. Now let's look at what happens when we push this button. When we push this button, it's going to connect pin 2 directly to ground, and so it's going to be 0 volts here, and you're still going to have 1.67 volts here. 1.67 is higher than 0, so the output of this comparator is going to go high, but that's not going to change anything because Q is already high, so that didn't do anything. And when you take your finger off the button, this is going to go low again. Now let's see what happens when you push the button at pin 4. So you push it, it's connected directly to ground, so then you're going to have current flowing to the reset of the SR latch, and that's going to reset the SR latch. So Q is going to go high, but that's not important because we haven't connected anything to pin 7, so it doesn't matter if not Q is high or low. All we care about is if Q is high or low. So Q is going to now go low because not Q is high, so you're going to see this LED turn off, and now this is going to be latched in even if you take your finger off the button. So if you take your finger off the button, the reset input to this SR latch is going to go low, but Q is still going to be low and not Q is still going to be high, because that's how SR latches work. And Q won't go high again until you push this button at pin 2, because that's going to directly connect pin 2 to ground. So you're going to have 0 volts at the negative input for this comparator. 0 volts is higher than 1.67 volts, so the output for this comparator is going to go high. You're going to set the latch, and then Q is going to go high again, and this LED is going to turn on. So that's what the bistable setup for the 555 timer does. When you push the button at pin 4, Q is going to go low and this LED is going to turn off. When you push the button at pin 2, the output's going to turn on and this LED is going to turn on, and that's all it does. It's just a way to switch, except it's debounced, so even if this button bounces, it's still only going to latch once. So now I'm going to build this circuit on a breadboard. So I'll start off by adding the 2 buttons, and then I'll put in the 555 timer. I'll pull up pin 4 with a 1 kilo ohm resistor, and I'll do the same to pin 2. I'll tie one of the inputs of the button low, and I'll also do the same for the other button. I'll connect pin 7 to the output of the second button, and I'll connect pin 2 to the output of the first button. I'm going to have to move this button over just a bit so that the wire reaches are cut it a little short, and I'll also have to move ground over too. I'll tie pin 6 low, and I'll hook up 5 volts to pin 8. I'll hook up ground to pin 1, and then I'll put a yellow LED in between pin 3 and a 220 ohm current limiting resistor, which then goes to ground. And now I got to connect the 2 sides of the power rails together because they're not connected at the middle. So I'll do that for the bottom VCC and the bottom ground, and then the top ground and the bottom VCC. So that's the entire circuit built on the breadboard. But one thing I do want to change about this is connect up 2 LEDs where one of the anodes is connected to the output but the cathode is connected to ground through a 220 ohm current limiting resistor, just like we had, but the other one's cathode is connected to the output and the anode is connected to 5 volts with a 220 ohm current limiting resistor, so that in each state of the bistable circuit there will always be one LED on. And now I got that set up, I'll plug in power and this should work. So one turns on, the blue one's just pulsing, I don't know why that's happening. I'll have a look at it. So I found out it was plugged into pin 4 instead of pin 3, so every time I pushed the button it was only pulsing for the amount of time I was pushing the button. So I'll switch that around now. So now everything works. When I push one button, one LED turns on. When I push the other LED turns on. So that's all working good. And the reason I did this is just to make it easier to see what mode we're in. And I forgot to add a 0.01 microfarad capacitor in between ground and pin 5, so I'll do that now. And now the circuit's fully complete, I'm ready to build this on EasyEDA. So I got EasyEDA open and now I'm going to build the circuit. So I'm going to need a 555 timer, and I'm going to need 4 resistors. Now I'm going to need 2 LEDs and 1 ceramic disc capacitor, and I'm also going to need 2 of these buttons. I'll move this over and I'll start out by hooking power and ground to pins 8 and 1. I'll connect ground to pin 6 and this ceramic disc capacitor to pin 5 and then to ground. I'll connect one of the LEDs cathode to the output and then one of the anodes to the output, just like that. Then I'll connect the current limiting resistor to both of them. Then I'll connect this one to ground and this one to 5 volts. Now I'll connect a 1k pull-up resistor to pin 2 and a 1k pull-up resistor to pin 4. I'll bring that up like that and that up like that. Then I'll connect the switches. I'll tie the inputs to ground and then connect the outputs to the pull-up resistors. Actually, that should be connected on this side of the resistor, and so does this. And now I'll connect the resistors to 5 volts. So that's the entire bistable circuit on EasyEDA, and now all we got to do for the clock is connect all of these circuits with some combinational logic, and then the clock will be done, but I'll do that in the next video. So thanks for watching.